Okay, so most substances on this graph show increased solubility as temperature increases. What are the exceptions? As temperature goes up, what does not increase as far as solubility goes? Just shout them out. You see it. Shout it out.
Cesium, sulfur.
Okay, cool. This is cerium. It's Ce, which is not one of the ones we memorized. So yeah, no problem with not knowing what that was. CeSO4. What was that, 3? And then we have NH3. Yeah, exactly. NH3. That's ammonia. All right. So as the temperature increases for these two, the solubility decreases. All right. Each curve shows how the solubility for that substance changes as blank changes. All right, so what's changing?
Temperature.
Yeah, good, the temperature. All right. The solubility of substances whose curves show a greater or steeper slopes are more or less affected by temperature changes. Yeah, more, exactly, good. All right, so they're more affected. So out of these, which one looks like it's affected the most? Yeah, there's a bunch. It's hard. This one looks pretty good. It almost looks exponential, right? Sort of. But yeah, I mean, you can say there's a bunch. An easier question is which one is affected the least? Yeah, NaCl. Sodium chloride. It's like right here. I missed it in the middle. But it just kind of, it goes from like 38 and then it stops at like 40. So that's pretty much flat. All right, cool. All right. So if 50 grams of water saturated with potassium chlorate at 23 degrees Celsius is slowly evaporated to dryness, how many grams of the dry salt will be recovered? All right, we need to write some stuff down. All right, first thing I would write down is the temperature. All right, so we're at 23 degrees Celsius. It says if 50 grams of water, what is this chart telling us as far as the water is concerned? Is it telling us 50? No, it's telling us 100, right? So we need to first figure this out at 100 grams of water, because that's what the chart tells us, all right? So I like to write this just like this over here, only kind of like sideways. So it's 100 grams of water, all right? And what are we talking about? What salts are we talking about in here? Yeah, potassium chlorate. All right, so potassium chlorate. And remember, the chart's going to tell us how many grams of potassium chlorate. So we want to fill in this right here, all right? So before we fill that in from the chart, let's look back and make sure that we understand where we got all these numbers from. One, the temperature was given. So the temperature is just whatever it is from the problem, 23 degrees Celsius. And then the rest of this is just the solute over 100 grams of water, because that's what this chart shows us, right? So we know it's potassium chlorate because of this, all right? So we need to first figure out this from the chart, and then we can cut it in half to figure out the water part, right? To figure out the unknown. All right, so let's figure it out. Where is KClO3, or potassium? Yeah, near the bottom. All right, cool. So it's this one, right? All right, right there. And we're looking for 23. So what do you think it is? Yeah, 10's a good guess, right? 10. And when we're talking about sig figs in here, the ones place is the guess, right? So you're not going to have decimal places when you're reading off of the periodic table, or the chart here. It's just going to be, you know, the ones place. You're going to make a guess here, and you guessed 10, right? Awesome. Okay, now this one we can do in our head. Most of them you can do in your head, but this is how you kind of show your work for it, because sometimes things get a little bit more complicated, all right? So this is the original, all right? Now we're going to do this how it changed for the actual problem here. Did the temperature change? No, so it's still 23 degrees Celsius, all right? We're looking for this. And now what's the amount of water? 50 grams of H2O, all right? How did you go from 100 to 50? Divided by 2, right? Exactly. So we just divide by 2. So we're going to take this number, divide by 2, and that would give us 5 grams. Yeah, exactly. All right.